this topic is chemical equilibrium. The content: first, chemical equilibrium. Second, types of chemical equilibrium, historical introduction, equilibrium expression, Le Chatelier principle, and factors that affect chemical equilibrium, conclusion. Chemical equilibrium is a condition which occurs when the concentration of reactants and products participating in a chemical reaction exhibit no net change over time. Chemical equilibrium may also be called a steady state reaction. Examples: ammonia is preparated for industrial use by Haber's process combining nitrogen with hydrogen under high pressure using iron as a catalyst. The contact process in the modern industrial method of producing sulfuric acid, whereas the fundamental reaction comprises the oxidation of sulfur dioxide into sulfur trioxide. Types of chemical equilibrium. There are two types of chemical equilibrium: is homogeneous equilibrium and heterogeneous equilibrium. Homogeneous chemical equilibrium: in this type of reaction, the reactants and the products of chemical equilibrium are all in the same phase. It is also divided into two types. Reactions having the number of molecules of the products is equal to the number of molecules of the reactants. For example, one molecule hydrogen with one molecule iodine is formed two molecular hydrogen iodide. All these products and reactants are gaseous. Reaction having the number of molecules of the products is not equal to the total number of reactant molecules. For example, two molecules sulfur dioxide with oxygen gas and is formed to sulfur trioxide. Heterogeneous chemical equilibrium. In this type of reaction, the reactants as well as the products of chemical equilibrium are present in different phases. Examples are given below. Carbon dioxide is gaseous. With carbon solid is formed two molecules carbon oxide is gases.
Historical interactions. The concept of chemical equilibrium was developed in 1803 after Berthollet found that some chemical reactions are reversible. For any reactions, mixtures to excite at equilibrium, the rates of the forward and backward reactions must be equal. Gilbert and Page, building on Berthollet's ideas, proposed the level of mass actions, where A, B, C, and D are active masses and K plus and K minus are rate constants. Since at equilibrium forward and backward rates are equal, and the ratio of the rate constants is also all constants, not known as an equilibrium constants, as shown below. Equilibrium constants.
Equilibrium expression. The equilibrium expression for a chemical reaction may be expressed in terms of the concentration of the products and the reactants. Only chemical species in the aqueous and the gaseous phases are included in the equilibrium expression because the concentrations of liquids and solids does not change for the chemical reaction. The equilibrium expression is the equilibrium constant equal ABCD, the molar concentrations of ABCD, and the rank is written in small letters ABCD coefficients in a balanced chemical equation. Next, Le Chatelier's principle. In 1884, Henry Louis Le Chatelier formulated the main principle of chemical equilibrium. If a system in stable equilibrium is influenced from the outside by changing of the equilibrium conditions, then processes aimed at compensating for external influences increasing in the system. In other words, when at least some factor affecting the equilibrium changes, the chemical system finds a new equilibrium point in order to minimize this change.
Factors that affect equilibrium include
As a reactant or product of change in concentration affects equilibrium, adding reactant can drag equilibrium to the right in a chemical equation where more product forms. Adding product can drag equilibrium to the left as more reactant forms. Second, changing the temperature alters equilibrium. Increasing temperature always shifts chemical equilibrium in the direction of the endothermic reaction. Decreasing temperature always shifts equilibrium in the direction of the exothermic reaction. For example, refers to exothermic reaction. If you increase the temperature, then according to Le Chatelier's rule, the equilibrium will shift in such a direction as to reduce its effect. In this case, to the left, as heat is absorbed in the reaction concentration, then increasing the temperature will shift the equilibrium to right. Second, changing the pressure affects equilibrium. For example, decreasing the volume of gas system, increasing its pressure, which increases the concentration of both reactants and products. The net reaction will see to lower the concentration of gas molecules. Conclusion. In conclusion, Le Chatelier's principle was observed in the experiment. The principle states that when the condition of a system in equilibrium are changed, the system reacts to counteract the change and restores equilibrium. The equilibrium is disturbed when any of the reactants or products are disturbed. The rate of this reaction depends on concentration of the solution, catalyst, pressure, and temperature.
The first laboratory work is displacement equilibrium in homogeneous system. First, mix 20 ml in beaker distilled water with a few drops of saturated solution of iron chloride and potassium cyanide.
The resulting solutions is divided into 5 legs. First, let's write the ionic equation. According to Le Chatelier's principle, the additions of starting substance will shift the equilibrium in the system to right towards the formations of the product iron cyanide.
Let's leave the solution in the first flask for comparison. Add iron chloride solution to the solution in another flask. The color intensity increased. This indicates an increase in the concentration of iron thiocyanide. The same thing happens when potassium thiocyanide is added.
Potassium and chlorine ions are not included in the ionic equation, and at first glance, potassium chlorine should not cause a shift in equilibrium. Add potassium chlorine to the thiocyanate solution. The color intensity has decreased, which means the equilibrium has shifted to the left. The reason for this is a change in the ionic strength of the solution, leading to a decrease in the activity of thiocyanate ions in iron ions. Add any other strong electrolyte, for example sodium sulfate, to the solution of iron thiocyanate. It shifts the equilibrium in the same direction as potassium chloride.
The second experiment is the effect of acetic acid on the equilibrium between chromate and dichromate ions. In the first glass there is hydrochloric acid, in the second glass there is alkali, and in the flask there is a solution of potassium chromate. The add acid to potassium chromate and orange-colored potassium bichromate is formed. We add alkali to potassium bichromate. The yellow color of potassium chromate is formed.